This video is an introduction to significant figures. We're going to be covering two things. First off, what is a significant figure? And then we're going to apply significant figures to measurements, which is why significant figures are relevant in the first place. In the next video, we'll be doing significant figures in calculations. So there are a few rules with significant figures. I always think that this looks a little bit more complicated than it really is. So the first rule is all non-zero digits are significant. So you don't even have to think about it. Whenever you see something that's not a zero, it's instantly a significant figure. Interior zeros are significant. So when a zero is in between two non-zero numbers, it's automatically significant. So this number right here, 28.03, that zero is in between other numbers. So this has four significant figures. Every single one of those digits is significant. This number, 407, also has a zero in front, in between two non-zero numbers. So it has three significant figures. All three of those numbers are significant. This number, 7.0301, those zeros are in between other numbers. So this would have five significant figures. Okay, so leading zeros are not significant. They only serve to locate the decimal point. So these are called place-holding zeros. They don't help us with the precision of the measurement. They are just holding the place. So So whenever we have a decimal, those leading zeros are not significant. So this just has two significant figures, and this only has one significant figure. And again, the leading zeros aren't helping with the precision of the measurement. They are simply holding a place value. The same thing goes with trailing zeros. So let me show you this number right here. If we see this number, we don't call it ambiguous. We say that there are two significant figures. These trailing zeros, the one in the ones place and the tens place, those two, they are simply placeholder zeros. They do not help us with the precision of the measurement. So there would be two significant figures. If the trailing zeros are after a decimal, so I want you to notice that 45 and 45.000, we would think of have the same value. So the reason why we have these zeros is because our measurement device tells us that it's not 45.01, okay? It's not 45.1, it's not 45, it's exactly 45.000. So in chemistry, precision is extremely important when making measurements and doing reactions, and that's why we have those zeros. It's showing us that this number is 45 to the thousandth place. Okay, it's so precise. Those are pretty much the rules with significant figures. So let's move on to some practice problems. So number 75D in chapter 1 says underline the zeros that are significant and draw an X through the zeros that are not. So we're looking at D. So these zeros are leading zeros. They're not helping with the precision of the measurement. So they are not significant. They are place-holding values. This zero is in between two non-zero numbers, so it is significant. And this zero is a trailing zero after a decimal point, so it is also significant. So both of those zeros are significant, and these three zeros are not significant. Number 77B asks for how many significant figures there are in the number. So in this case, there is 1, 2, 3 non-zero numbers, so we know that those are significant, and these are trailing zeros, and there's no decimal. So whenever we have trailing zeros without a decimal, they are not significant. Here we have a trailing zero with a decimal point, so it is significant. In regards to measuring with significant figures, this is very, very important, especially during labs. So the first step that you need to do is figure out what is the marking. What does this tick mark mean? So notice this big line means 4 and this big line means 5. There are 10 tick marks in between 4 and 5. So we can assume that each tick mark is going to be 0.1. So at that first tick mark, it would be 4.1. That second tick mark would indicate 4.2. Okay? So when we measure with a graduated cylinder, when we measure liquid, especially the liquids that we'll be using, we measure from the bottom of the meniscus. So we're not measuring from up there. You do not do that. You measure from the bottom of the meniscus, the bottom of that little dip. So if we count, it would be 4.1, 2, 3, 4, 5. So it's somewhere in between 4.5 and 4.6. It's a little closer to 4.6. So we're going to say 4.58. Okay, so this last digit, notice there's no tick mark for that 8. That's called the uncertain digit. And whenever you're measuring, you go one more significant figure than your measurement device. So notice our measurement device goes to the 10th place, so we are going to go to the 100th place when reporting the measurement, okay? Because we know it's not exactly 4.5, it's not exactly 4.6, it's somewhere in between, so we're going to take that guess. That tells whoever is looking at our measurement that we use the device that was accurate to the 10th place, and it just makes our measurement a bit more accurate.